Welcome to the video for direct and inverse variation, or direct and inverse proportions. We started to talk about direct proportion, but really didn't get into it in the video on rates and proportions. Direct proportions and directly proportional relationships directly relate to proportions. And hopefully we'll see that in this video. Quick look at this problem. Think about it for a minute. Pause the video. Think about how you would solve it. But a catering company makes chocolate chip cookies for their box lunches. They use 9 bags of chocolate chips weighing 24 ounces each. For a recipe that feeds 50 people, how many bags would they use for an event with 100 people or 250 people? Think about how you might solve that based on things we've done recently, and then just intuitively how you would solve it. Once you've done that, restart the video. All right. Most people intuitively are going to say, well, for 100 people, you need twice as much. And from there, you can kind of solve the rest of the problems. I'm hoping that some of you noticed that you could do this with a proportion. And actually, whether you write the proportion or not, in your mind, you may not be using proportions, but you may not realize you're using proportions, but you really are. So we're saying 9 bags per 50 people, X bags per 100 people. Multiply both sides by 100, and we get 18. If we want to do 250, we do 9 per 50. Now, before I do that, getting ahead of myself, to actually solve this proportion, we multiply both sides by 100. And then we get x equals 18. To do 250, 9 divided by 50 equals x divided by 250. Multiply both sides by 250. That's 250, trust me. And we would end up with getting x to be 45. 45 bags if they have 250 people. Well, hopefully by now you kind of see a pattern. So we can actually, whatever number of people we have, we're going to multiply by 9 over 50. So when we think of this in terms of direct variation, we're going to go directly to that point. So we're going to say the number of bags. Instead of using x, I'm going to use b equals 9 over 50 times the number of people, p. And in your work with the computer, you're probably seeing that in this way more often, 9 over 50 times p. So we just take the number of people multiplied by the constant of proportionality, or constant of variation, or just constant. And if I go to Excel will let me put in a formula. So I can say I want this to be equal to the number of people, cell A7, times 9 divided by 50. And that gives me the 18. And I'm going to copy that down. And as you can see, for every 50 people, we have 9 bags. 9, 18, 27. Looks like I skipped 200. I hate to leave things untidy. And as you can see, as we graph it, there we go. As we graph it, the relationship shows up as a straight line. And that's what we call direct variation, or a directly proportional relationship. It's based on solving a proportion, but if we solve it using the variables P and B, we don't have to write the proportion every time. We've actually written an equation that allows us to calculate the number of bags based on the number of people. So that's direct variation, or direct proportion, and there's a constant of proportionality. Take a look at this question now. Same story, different approach. So they use 9 bags of chocolate chips, weighing 24 ounces each. The chocolate chip supplier doesn't want to raise the price, but they want to make more money. So all of a sudden they change their bags to 18 ounces. How many bags does the caterer need? And you'll notice we're going to also ask the question, what if they change it to 12 ounces, 8 ounces, 6 ounces? And all of a sudden the caterer gets tired of the chocolate chip supplier constantly lowering the quantity instead of raising the price, and they go to a different supplier that has 36 ounces per bag. What happens to the number of bags under those conditions? Restart the video once you've thought about how you would, first of all, answer the first question. How many bags do you need of each? Okay. Now that you've thought about that, my experience has been most people will say, I need 9 times 24 chocolate chips, or ounces. 9 times 24 equals 240 minus 24. I need 216. I hope that's right. 216 ounces of chocolate chips for one recipe. It doesn't matter how many are in a bag. That's how many I need, 216. So if we go to 18 ounces, we're going to have the number of bags times 18 equals 216. We go to 36. Then I'm going to, we'll do that first. If I go to 36, I'm going to multiply my bags times 36. I will need to get 216. So in this case, the number of bags equals 216 divided by 18. I don't want you to wait for me to try to figure out that. With my calculator. So, first of all, 9 times 24. Yeah. Divide that by 18, and I get 12. So I need 12 bags. If I divide it by 36, I'd end up with B equals 4 bags. That's not right. Let's just do it. 216 divided by 36, 6 bags. So I'd end up with 6 bags. So you see, I'm always multiplying to get 216 because I know that's how many ounces I need. So I'm going to look at a formula now because we've got the weight per bag. What I've been doing is plugging that in and then just solving the problem, solving the multiplication problem. So I took the number of bags times the weight has to equal 216 ounces. If I want to know the number of bags, I take the bags and I take 216 and I divide by the weight. Or there's another way to look at it. We have one. We can say we're multiplying 1 over W times 216. And 1 over W, you'll notice, is the reciprocal of W, the reciprocal of the weight. The reciprocal is also referred to as the multiplicative inverse. So we'll notice what we're saying here is that the number of bags is proportional to the reciprocal or the multiplicative inverse of the weight. So we say the bags are inversely proportional to the weight. And if I go to my Excel formula, I can actually put that in. I will say the bags equals 1 divided by the weight, which is A6, times 216. So I've got my formula there. I can copy that formula down. And looks like I copied the little dot that I accidentally made. But you will notice, if you look at the graph, that as the weight per bag increases, so if I increase the weight per bag, then I decrease the number of bags. If I come back to my direct variation, if I increase the number of people, I increase the number of bags, what we call directly proportional. When we increase the weight, we decrease the number of bags we need. That is inversely proportional. And you'll notice it all has to do with how we do our constant of proportionality. Here my constant, I multiply it by 1 over W. Here I multiply my constant times the P, not times 1 over P. Another place that this really shows up is in chemistry. So if we look at an internal combustion engine, and we think about what happens, the piston starts at top dead center. And the gas inside has been compressed. There's a certain amount of gas inside. Gas being not liquid, not gasoline. It's actually a mixture of air and evaporated gasoline. So gas meaning that it's in the gaseous state. So we have that compressed. The piston is ready to fire, and the spark plug fires the piston, and all of a sudden the gas combusts. The temperature of the mixture increases very rapidly. So if we draw a graph, and I didn't leave myself enough room. If we draw a graph of the pressure, come on, and the temperature, what we find is when we increase the temperature, we increase the pressure, which is good because that's what makes the car go. So initially, increase the temperature, increase the pressure. Then the piston goes down and turns the crankshaft. So as the piston goes down, I don't want it to go too far because my graphics don't go that far, but I want it to go faster. So I don't want it to go too fast anyway. The piston goes down. So once the piston starts to go down, then I have another situation. The temperature doesn't really change in the engine because it happens so fast. The temperature doesn't change. So, but as we are increasing, as the piston is going down, the volume that the gas is occupying going up. As the piston goes down, there's more space in the cylinder. So if we look at our pressure after the initial combustion, the pressure starts out really high, and as the volume increases, the pressure decreases until the piston gets down to the bottom, and then as bottom dead center, it gets ready to go back up and push the valves open, and you push the exhaust gases out. But what we've talked about so far is not the part of the cycle where the valves are open. We're just talking about constant volume of gas, or a constant amount of gas. The temperature changes, the pressure changes, and the volume changes. So initially, we have the pressure is equal to some constant times the temperature. And I put a 1 by the K because I'm going to use that in other places. If we look at the part where the piston is going down, then we have the pressure is equal to some constant, not necessarily the same. In fact, definitely not the same as the one in the pressure and temperature equation. But it's going to be K times 1 over the volume because we have an inverse relationship here. A lot of times you will look at that in terms of putting them all together. So we will say that P equals some constant, different than the other two constants, times the temperature divided by the volume. So some of the problems I've seen, you're given This variable is inversely proportional to the other variable, and it's directly proportional to the other variable. So in this case, P is directly proportional to T, and it is inversely proportional to V. So we can say P equals a constant times T divided by V. And a lot of times you'll see that in chemistry class, you'll see it written PV equals K3T, and actually they'll put NR T, where N is the number of moles, and R is actually what's called the universal gas constant. But we don't really need to know that. But when you're told that there's a direct variation, you can write P equals KT. When you're told there's an inverse variation, you write P equals K over V. When you're told there's both, you can put them both in the same equation. A lot of the problems then will tell you, hopefully once you write this equation, then the problem will tell you if the pressure, if the volume is this, the temperature is this, the pressure is this. They will want you to plug those numbers into this equation and actually find the constant. That's the only other thing you might have to do. But hopefully this kind of gives you an idea what direct and indirect variation are, and kind of how to tell the difference.